You know, there's something deeply humbling about looking up at the night sky and asking yourself whether we're alone. It's a question that has captivated humanity for as long as we've been capable of wonder. And yet, despite all our advances in science and technology, despite our sophisticated telescopes and our deep mathematical understanding of the cosmos, we still don't have an answer. But here's what might be even more troubling. The more we learn about the universe, the more we understand about the nature of space, time, and the extraordinary distances that separate one star from another, the more we begin to realize that the question might not be whether intelligent life exists elsewhere, but whether it's even possible for us to ever find it. Now, when I say impossible, I don't mean it in the casual sense that we sometimes use when something is merely difficult or unlikely. I mean something more profound, something that touches on the very fabric of reality itself. The universe, as we've come to understand it through physics, imposes certain limitations, certain boundaries that aren't just technological hurdles we might one day overcome with better engineering or more powerful rockets. These are fundamental constraints built into the structure of space-time itself, woven into the equations that govern everything from the smallest quantum particles to the largest galaxy clusters. And when you really sit with these constraints, when you allow yourself to feel the weight of what they mean, you start to see why the search for intelligent life might be one of the most poignant endeavors in all of human history. Let's start with something we can all relate to: distance. We measure distance in miles or kilometers in our everyday lives, and these measurements feel tangible and real. You drive 10 miles to work, you walk 3 kilometers to the store, and you have a visceral sense of what those distances mean. You know how long it takes, how it feels, what it requires of you. But when we shift our perspective to the cosmos, these familiar units become almost laughably inadequate. The nearest star to our sun, Proxima Centauri, is about 4.2 light years away. Now, a light year is the distance that light travels in 1 year, and light moves at about 186,000 miles per second. Let that sink in for a moment. In the time it takes you to snap your fingers, light has traveled far enough to circle the Earth more than 7 times, and yet even at this incomprehensible speed, it would take light more than 4 years to reach Proxima Centauri. If we wanted to send a spacecraft there with our current technology, we're looking at tens of thousands of years of travel time. The Voyager probes, humanity's most distant ambassadors launched in the 1970s, are only now leaving the immediate neighborhood of our solar system, and they're traveling at about 38,000 miles per hour relative to the sun. At that speed, it would take them more than 70,000 years to reach Proxima Centauri, if they were headed in that direction, which they're not. So already, with just the nearest star, we're confronting timescales that dwarf all of recorded human history. Every empire that has ever risen and fallen, every language that has ever been spoken, every work of art that has ever been created, all of it fits multiple times over into the journey time to our closest stellar neighbor. But here's where it gets even more challenging. Proxima Centauri is just one star in a galaxy of hundreds of billions of stars. And if we're talking about finding intelligent life, we're not just looking for any star, we're looking for stars with planets, planets that are in the habitable zone where liquid water might exist, planets with the right chemistry and the right atmospheric conditions, planets where evolution has had enough time to produce not just life, but complex, intelligent, technologically capable life. The odds of any given star meeting all these criteria are, well, they're not great. Even if we're optimistic and say that 1 in a million stars might harbor intelligent life, in our galaxy alone, that would still mean there could be hundreds of thousands of intelligent civilizations out there. But they're spread across a disk of stars that's about 100,000 light years in diameter. Now, we're not talking about traveling to the next town over. We're talking about distances so vast that light itself, the fastest thing in the universe, takes 100,000 years to traverse our galaxy from one edge to the other. And this is where the fundamental physics really starts to constrain us. According to Einstein's special theory of relativity, nothing with mass can travel at the speed of light. Nothing. This isn't a technological limitation. This isn't about not having powerful enough engines or efficient enough fuel. This is a statement about the structure of space-time itself. As you accelerate an object closer and closer to the speed of light, its mass effectively increases, requiring ever more energy to accelerate it further. To actually reach the speed of light would require infinite energy, which is another way of saying it's impossible. So, we're stuck traveling at some fraction of the speed of light, and even if we could somehow build a spacecraft that could travel at, say, 10% of light speed, which would be an extraordinary achievement requiring technology far beyond anything we currently possess, it would still take 42 years to reach Proxima Centauri. And remember, that's the nearest star. To explore even a modest volume of our galaxy, to visit enough star systems to have a reasonable chance of encountering intelligent life, we'd be looking at missions lasting thousands or even millions of years. The human beings who began such a journey would be separated by hundreds or thousands of generations from those who might see it completed. But let's set aside the practical challenges of building generation ships or achieving near light speed travel. Let's imagine that some civilization out there, either us in the distant future or another species altogether, has somehow solved these problems. They've built the ships, they've mastered the technology, they've committed to the multi-generational voyage. Even then, there's another, perhaps even more fundamental obstacle. Time itself and the way time interacts with the expansion of the universe. You see, the universe isn't static, it's expanding, and not just expanding, but expanding at an accelerating rate. Every galaxy that's not gravitationally bound to our own local group is moving away from us. And the farther away it is, the faster it's receding. This means that there's a kind of cosmic horizon, a boundary beyond which galaxies are moving away from us faster than light can travel through space to reach us. Now, you might object that I just said nothing can travel faster than light, and you'd be right. But the expansion of space itself isn't limited by the speed of light. Space can expand as fast as it wants, and it's carrying galaxies along with it. From our perspective, these distant galaxies are disappearing beyond an event horizon, and we will never, ever be able to reach them or receive signals from them, no matter how long we wait or how fast we travel. Currently, this cosmological horizon is about 46 billion light years away, which gives us a pretty large observable universe to work with. But here's the unsettling part. As the universe continues to expand and accelerate, this horizon is, in a sense, getting closer. More precisely, galaxies that are currently within our observable universe will, over time, be pushed beyond our cosmic horizon by the expansion of space. Trillions of years from now, if there are any observers left in the universe, they'll look out and see a much lonelier cosmos than we do today. Most of the galaxies we can currently see will have receded beyond the horizon, their light stretched to infinite wavelengths rendered forever invisible. This has profound implications for the search for intelligent life. If there's a civilization in a galaxy that's near the edge of our observable universe right now, we have a window of time in which communication is possible, but that window is closing. Eventually, the expansion of space will make it impossible for any signal they send to ever reach us, and vice versa. From their perspective, we will effectively cease to exist in their observable universe, and we in theirs. The cosmos is actively separating us, creating islands of causality that can never interact no matter what technology we develop. And this brings us to something even more subtle and in some ways even more troubling: the nature of time and simultaneity in an expanding universe. When we look out at a distant galaxy, we're not seeing it as it is now. We're seeing it as it was when the light left it perhaps millions or billions of years ago. In a very real sense, there is no universal now that encompasses us and that distant galaxy. Einstein's relativity taught us that simultaneity is relative, that observers in different states of motion will disagree about what events happen at the same time. But in an expanding universe, this relativity of simultaneity becomes even more pronounced. Imagine we detect a signal from an intelligent civilization in a galaxy a billion light years away. The signal was sent a billion years ago when that civilization was at a certain stage of development. But by the time we receive it, a billion years have passed for them as well. What has happened to them in the meantime? Have they thrived and expanded? Have they destroyed themselves in some catastrophic war or environmental collapse? Have they transcended biological existence and become something we wouldn't even recognize as life? Or have they simply gone extinct, victims of any number of cosmic or planetary disasters? We have no way of knowing. The information we receive is ancient history, and by the time we could send a response and they could receive it, another 2 billion years will have elapsed. This temporal disconnect means that even if we do detect intelligent life, we're not really having a conversation. We're finding echoes, archaeological artifacts encoded in electromagnetic radiation. Each transmission we might receive is like opening a time capsule from a civilization that might not even exist anymore by the time the message reaches us. And if we respond, we're essentially writing a letter to the distant future of that civilization, hoping that they'll still be there to receive it, that they'll still care, that they'll still remember they sent the original message. Now, you might think that at least within our own galaxy, the distances are manageable enough that real communication could occur. After all, even if a civilization is 50,000 light years away on the far side of the Milky Way, that's a long time, but not impossibly long in the grand scheme of things. You could imagine an exchange of information, even if each round trip took 100,000 years. But here's where we have to confront another uncomfortable truth: the question of time scales and the lifespan of technological civilizations. How long does a technological civilization last? We have exactly one data point: us. And we've been capable of sending and receiving radio signals for less than a century. In cosmic terms, that's not even a blink of an eye. It's an infinitesimal sliver of time. And already, in this brief period, we've developed the capacity to destroy ourselves through nuclear weapons. We're altering our planet's climate in ways that could have catastrophic consequences. And we're creating artificial intelligences that might surpass us in ways we can't predict or control. The question isn't whether we could destroy ourselves, it's whether we'll manage not to. Some researchers have tried to estimate the average lifespan of a technological civilization, and the numbers are sobering. If most civilizations go through a period of great danger once they develop certain technologies, a kind of cosmic adolescence where they either mature into a stable, sustainable society or destroy themselves, and if the odds aren't particularly in favor of survival, then the average civilization might only broadcast radio signals for a few hundred or a few thousand years before either falling silent or evolving beyond the need for such primitive communication methods. What this means is that even if intelligent civilizations are relatively common in the galaxy, the chances of two of them existing within communication range at the same time might be vanishingly small. Imagine the galaxy as a vast dark room, and each civilization is like a firefly that lights up briefly before blinking out. Even if there are thousands of fireflies in the room, if each one only lights up for a fraction of a second and they're spread out across the entire space, the chances of two of them being lit at the exact same moment and being able to see each other are incredibly slim. This is sometimes called the temporal problem in the search for extraterrestrial intelligence. Even if space were full of civilizations, the dimension of time might keep them isolated from one another. We might be like ships passing in the night, each of us calling out into the darkness, but our messages arriving only after the other has already moved on or fallen silent. And then there's the question of what we're even looking for. When we search for intelligent life, we're typically searching for technological signatures, radio signals, laser pulses, perhaps evidence of large-scale engineering projects like Dyson spheres that would alter the light we receive from stars. But this assumes that other civilizations use technology in ways that are at least somewhat similar to how we use it. What if they don't? What if a sufficiently advanced civilization develops technologies that are so far beyond our current understanding that we literally wouldn't recognize them as technology? Arthur C. Clarke famously said that any sufficiently advanced technology is indistinguishable from magic. But we might take this further and say that any sufficiently advanced technology is indistinguishable from nature itself. If a civilization has been around for millions or billions of years, if they've had that much time to develop and refine their understanding of physics, they might operate on principles we haven't even discovered yet. They might communicate using methods we can't detect. They might exist in forms we can't perceive. They might have concerns and motivations so alien to our own that we'd share no common ground for understanding. There's also the uncomfortable possibility that intelligence itself might not be as durable or as advantageous a trait as we'd like to think. We often assume that intelligence is the pinnacle of evolution, that it's an inevitable outcome of natural selection on any planet where life emerges. But what if that's not true? What if intelligence, particularly the kind of abstract technological intelligence that humans possess, is actually a cosmic fluke, a strange quirk of evolution that happened once on a particular planet under very specific circumstances? What if most life in the universe is bacterial or fungal, or exists in forms so different from anything we know that we wouldn't recognize it as life at all? Even on Earth, intelligence of the human variety is a very recent development. Life has existed on our planet for about 3.5 billion years. Complex, multicellular life has existed for perhaps 600 million years. But humans, with our capacity for abstract thought, language, and technology, have only been around for a few 100,000 years. And we've only had civilization for about 10,000 years. We represent a tiny fraction of a percent of the total history of life on Earth. And we have no idea whether we're a sustainable form of life or just a brief bright flame that will burn out quickly and be replaced by something else, something perhaps more durable but less technologically oriented. Consider the dinosaurs. They dominated the planet for about 165 million years. That's more than 500 times longer than we've been around. And as far as we can tell, they never developed technology, they never built telescopes or radios, they never wondered about their place in the cosmos. If intelligence and technology are supposed to be such great evolutionary advantages, why didn't they develop them? Why did it take a cosmic catastrophe wiping them out and creating an opening for small mammals to eventually evolve into us for intelligence to emerge? Maybe intelligence isn't particularly special. Maybe it's just one strategy among many that life can pursue and not necessarily the most successful one. Bacteria have survived for billions of years and will likely outlive us by billions more. They're adaptable, resilient, and they don't require complex social structures or resource-intensive brains. From an evolutionary perspective, they're wildly successful. So maybe when we look out at the universe and ask where all the intelligent life is, we're asking the wrong question. Maybe the universe is teeming with life, but most of it is simple, single-celled, and has no interest in or capacity for building radio transmitters. But let's say we're optimistic. Let's say that intelligent technological life does arise with some regularity in the universe, that we're not unique in that regard. Even then, there's the problem of what we might call cosmic timing. The universe is about 13.8 billion years old, and it's going to continue existing for an incomprehensibly long time into the future. Stars will keep forming and dying for trillions of years. In this vast expanse of time, the few thousand years during which human civilization has existed is less than a rounding error. It's like one frame in a movie that's going to run for billions of years. Now, imagine that intelligent civilizations arise at random times throughout this cosmic history. The chances that two of them arise within a few thousand years of each other, close enough in time that they could potentially communicate before one or both go extinct or evolve into something else, are incredibly small. It's like dropping 2 grains of sand onto opposite ends of a beach and expecting them to land at exactly the same time. The vast majority of intelligent civilizations that will ever exist in the universe probably won't overlap in time with any other civilization. And this brings us to a particularly melancholy thought. It's possible that the universe will produce countless intelligent civilizations over its lifetime, each one asking the same questions we're asking, each one looking out at the stars and wondering if they're alone, and yet each one living and dying in cosmic isolation, never knowing that there were others, never making contact, never sharing their discoveries or their art or their understanding of existence. They'll each figure out the laws of physics, each one will discover quantum mechanics and relativity, each one will wonder about the nature of consciousness and the meaning of life, and then each one will fade away, leaving no trace that could be detected by the next civilization that arises millions or billions of years later. From a certain perspective, this is the ultimate cosmic loneliness. It's not that we're alone in the universe, it's that we might as well be, because the universe is structured in such a way that contact between civilizations is not just difficult, but perhaps genuinely impossible. The distances are too vast, the timescales too long, the expansion of space too relentless. But there's another layer to this that we should consider, and it has to do with the nature of information and communication over cosmic distances. When we send out a radio signal, it spreads out in all directions, getting weaker and weaker as it travels. The signal strength falls off with the square of the distance, which means that by the time a signal has traveled even a modest cosmic distance, it's been diluted to almost nothing. It becomes indistinguishable from the background noise of the universe. To detect such a signal, you need incredibly sensitive instruments, and you need to be looking in the right direction at the right time, at the right frequency. The universe is vast, and the number of possible directions to look, the number of possible frequencies to monitor, the number of possible times to listen, these are all astronomically large numbers. Even if civilizations are broadcasting, even if they're trying to make contact, the chances of us accidentally stumbling across their signal are vanishingly small unless they're relatively nearby and broadcasting very powerfully. And here's the thing, broadcasting powerfully into space requires enormous amounts of energy. Why would a civilization do that? For us to detect them, they'd essentially have to be shouting into the void, spending vast resources on the off chance that someone might be listening. It would be like standing in the middle of a desert and yelling as loud as you can, hoping that someone on the other side of the planet might hear you. It's not impossible, but it's not very efficient, and it's not clear why any civilization would make that choice. More likely, any civilization that develops radio technology eventually moves on to more sophisticated forms of communication. They might use highly focused point-to-point transmissions that don't spread out into space. They might use optical signals or neutrinos or gravitational waves or some other medium we haven't even thought of. They might communicate in ways that are so efficient and so tightly controlled that they don't leak much signal into space at all. And if that's the case, then the window during which a civilization is inadvertently broadcasting detectable signals into space might be very brief, maybe just a century or two, which in cosmic terms is nothing. We ourselves are already starting to move in this direction. Modern communication technology is much less leaky than the powerful broadcast transmitters we used in the mid-20th century. We use satellites, fiber optics, spread spectrum signals that are hard to detect even if you're looking for them. In another century, we might be essentially radio quiet from the perspective of distant observers. And if that's a common pattern, if civilizations generally go through a brief radio loud phase before moving on to quieter technologies, then the number of civilizations we could potentially detect at any given time becomes even smaller. There's also the question of whether we'd even recognize an alien signal if we saw one. We're looking for patterns that seem artificial, patterns that don't occur in nature. But what if alien communication looks like noise to us? What if it's compressed or encrypted in ways that make it indistinguishable from random static? Modern data compression and encryption algorithms are specifically designed to make data look as close to random as possible. That's a feature, not a bug. It makes the data more robust and more secure. An alien civilization might use similar techniques, and their communications might pass right through our detectors without us ever realizing what they were. Or consider this. What if communication isn't even the right framework to think about? What if advanced civilizations don't communicate in the sense that we understand it? What if they've developed some form of collective consciousness, or they upload themselves into digital substrates, or they exist in higher dimensions, or they've learned to manipulate quantum entanglement in ways that allow instantaneous information transfer? These ideas might sound like science fiction, but the point is that we really don't know what's possible. We're extrapolating from our own experience, from our own technology, from our own understanding of physics. And that understanding, while impressive, is still incomplete and might be missing crucial pieces. We've been doing physics for a few hundred years in any serious way. The universe has been around for nearly 14 billion years. It seems presumptuous to assume that we've already figured out all the fundamental principles, that there are no more discoveries waiting that would radically change what we think is possible. A civilization that's been around for 1 million years might know things about the universe that would seem like magic to us, and they might communicate and operate in ways that are completely invisible to us with our current level of understanding. And then there's the perhaps most unsettling possibility of all. Maybe advanced civilizations are out there, maybe they've detected us, maybe they're watching us right now, and they've simply chosen not to make contact. This is sometimes called the zoo hypothesis. The idea is that sufficiently advanced civilizations might have some kind of non-interference policy, like the Prime Directive in Star Trek. They don't want to contaminate less developed civilizations with their technology or their presence. They want to let us develop naturally, to figure things out on our own. If this is true, then the universe might be full of intelligent life, but we're being quarantined, kept in a kind of cosmic preserve where we're observed but not contacted. From our perspective, we'd appear to be alone, but it would be an illusion. We'd be like someone living in a nature preserve, unaware that they're being watched, unaware that there's a whole wider world beyond the boundaries of their experience. Now, I want to be clear that I'm not endorsing any particular explanation for why we haven't found intelligent life. I'm simply trying to illustrate the vast space of possibilities, the many different ways that the search could be futile, even if intelligent life is common. And when you step back and consider all of these factors, the distances, the time scales, the expansion of the universe, the potential brevity of technological civilizations, the possibility that we're looking for the wrong things or in the wrong ways, the idea that we might be living at the wrong time or in the wrong place, when you consider all of this together, the picture that emerges is one where contact between civilizations is not just unlikely, but potentially impossible in any meaningful sense. This raises profound questions about our place in the cosmos and about the nature of existence itself. If we are alone, if we're the only intelligent observers in a vast, empty universe, then that places an enormous weight of responsibility on us. We become the universe's way of knowing itself, the only consciousness that can contemplate the mathematical beauty of the laws of physics, the only entities capable of creating art and music and literature, the only beings who can wonder and question and search for meaning. The loss of human civilization would not just be a tragedy for us, it would be a cosmic tragedy, the silencing of the only voice that was speaking into the void. But if we're not alone, if there are others out there separated from us by unbridgeable distances and insurmountable barriers, then we're each living in our own cosmic bubble, each civilization a universe unto itself, unable to share what we've learned or who we are. In some ways, this might be even more lonely than being truly alone, to know that others exist, but to be forever cut off from them, to be so close and yet impossibly far. There's a strange kind of poignancy to the human endeavor when viewed through this lens. We build our telescopes, we send out our signals, we listen for responses that may never come. We do this knowing at some level that the odds are stacked against us, that the universe seems almost designed to keep its inhabitants isolated from one another. And yet we keep looking, we keep searching, because the alternative to simply give up and accept our isolation is somehow intolerable to us. It goes against something fundamental in human nature. This desire to reach out, to connect, to find others like us in the vastness of space. Maybe that's what makes the search meaningful, not the likelihood of success, but the act of searching itself. Maybe the value isn't in finding an answer, but in the fact that we're the kind of species that asks the question, that refuses to accept ignorance, that insists on reaching beyond our grasp, even when the reach seems futile. There's a kind of nobility in that, a defiance against the cosmic order that would keep us confined and isolated. And perhaps there's a lesson in all of this about the preciousness of the connections we do have. If the universe makes it so difficult for consciousness to reach across the void and touch other consciousness, then maybe we should pay more attention to the conscious beings right here with us. Every human connection, every moment of understanding between two minds, every instance of shared experience or empathy or love, these are rare and precious things in a universe that seems intent on keeping minds separate and alone. When you think about it, the fact that you and I can communicate right now, that I can have thoughts and encode them into words, and you can decode those words and hopefully have similar thoughts, that's a minor miracle. We're separated by space and possibly by time if you're watching this recording. But through the medium of language and technology, we can bridge that gap, at least partially. We can share ideas. We can think together. We can create a temporary fusion of minds. And if such connections are difficult, even within the same species on the same planet, how much more impossible must they be across light years and millennia? So perhaps the impossibility of finding intelligent life out there, far from being a depressing conclusion, is actually a call to appreciate what we have here. It's a reminder that consciousness is rare, that intelligence is precious, that the ability to wonder and question and understand is not something to be taken for granted. We might be alone in our corner of the universe. We might be separated from our cosmic siblings by distances and times that can never be crossed, but we have each other, and that's something extraordinary. The universe is 13.8 billion years old and contains hundreds of billions of galaxies, each with hundreds of billions of stars. The scale is beyond human comprehension, and somewhere out there, perhaps, other minds are also looking up at their night sky and asking the same questions we're asking. They're wondering if they're alone. They're searching for signals that never come. They're grappling with the same cosmic isolation that we feel. And maybe there's some comfort in that, in knowing that even if we never meet, even if we never communicate, we're united by our shared experience of wonder and loneliness and the desperate hope that somewhere, somehow, there might be someone else looking back. But whether we ever find them or not, whether contact is possible or forever beyond our reach, the search itself tells us something important about who we are. We're the species that builds telescopes and radios and sends messages to the stars. We're the ones who look up and wonder. We're the ones who refuse to accept the isolation that the universe seems to impose on us. And maybe in the end that's enough. Maybe the meaning isn't in the discovery but in the search, not in the answer but in the question, not in the destination but in the journey. The universe has given us the capacity to understand it, to unravel its mysteries, to peer into the depths of space and time and see the mathematical patterns that underlie everything. It's given us the ability to wonder why we're here, to search for others like us, to reach beyond our planetary boundaries and imagine what might be possible. And if those abilities turn out to be unique in the cosmos, if we're the only ones who have this gift, then we have an obligation to cherish it, to use it well, to make the most of our brief moment of consciousness in an otherwise unconscious universe. So when we ask whether it's impossible to find intelligent life out there, maybe the answer is both yes and no. Yes, the physics seems to stack the deck against us. The distances are too great, the timescale's too long, the universe too vast and too old and too indifferent to our desires. But no, because the search continues, because we haven't given up, because every night somewhere on Earth there are people pointing their instruments at the sky and listening, hoping, wondering, and as long as we keep searching, as long as we keep asking the question, we're proving that even if contact is impossible, the human spirit is capable of reaching toward the impossible anyway. That might be our defining characteristic, the thing that makes us who we are. We're the species that reaches for the unreachable, that dreams of the impossible, that refuses to be confined by the limitations that the universe places on us. And if there are others out there, others who share this quality, then maybe in that shared refusal to accept cosmic isolation, in that shared determination to reach out despite the odds, we're already connected in some meaningful way, even if we never exchange a single photon of information. The universe is a lonely place, vast beyond imagining and seemingly intent on keeping its inhabitants separate and isolated. But it's also a place of profound beauty and mystery, a place that has somehow given rise to consciousness and wonder and the ability to understand, at least partially, the nature of reality itself. And maybe that's the real message, the real meaning we should take from all of this. That we're here, that we're conscious, that we're searching, and that against all odds, despite the impossibility of it all, we continue to hope that somewhere out there, someone else is doing the same thing. And perhaps, in the grand scheme of things, that hope is more important than any answer we might find.